Good morning, class. It's expected that you'll take notes on this lesson. This is our lesson for Monday, Unit 1, Lesson 8, Properties of Similar Polygons. Please take notes. You need to be in your textbook, Chapter 7, Lesson 4, pages 545 to 550. If you haven't taken out your textbook yet, do so now. You can pause this video at any time. If you want to write down anything, you need to write down all the notes. They'll be checked on Friday when I get back. Today's lesson objective is that you will determine if polygons, that's a multi-sided object, are similar by comparing corresponding, that means sides and angles, congruent angles in similar objects, and corresponding proportional sides. So the angles are going to be congruent in a similar object. The sides are going to be proportional if they're similar. Also, you're going to use proportions of corresponding sides to find missing measures. We have two essential questions that we are still focusing on, 1 and 2. After this lesson, we will move on to the third and fourth essential question. We know that two figures are congruent under a rotation, a translation, and a reflection. Under essential question number 2, how do you know if when two figures are similar? And we've discussed this already, that two figures are similar when their angles are congruent and their sides are proportional. Please add these notes. Again, you can pause the video at any time if you need to take down notes. Okay, moving on to the book. Today we're in Lesson 4, Properties of Similar Polygons. A quick scan of the lesson. If you turn the page, we're on page 545. A quick turn of the page, we'll see our two major ideas here of similar polygons. If two polygons are similar, then their corresponding angles are congruent and the measures of their corresponding sides are proportional. One thing we've talked about in a previous lesson is that you have to find and mark up the corresponding angles. Here, the book's done a poor job, like we've talked about before, that they've just named this angle A. The problem there being if another line comes in, you're going to have multiple angles here. So it should have been named as angle, and add this to your book. BAC is congruent BAC. We tap it out. A being the vertex, so it's in the middle. YXZ. Angle YXZ. So we go through and we match up, and there's 3 congruent angles. That's why there's a single mark, a double mark in red, and a triple mark. Next we would look, we have 2 triangles. This one's smaller than that one. So the sides, if we mark them, AB we would mark with a single dash. Add that to your book. So you would put AB, the side length of AB, that's what this is. That's a line segment mark over XY here with a single mark and a line segment. Again, the book has done a poor job here of adding you need a line above the 2 letters to indicate that it's a line segment. And of course, the figure should be marked with 2 marks here and 3 marks. So add those into your book right now. The second, under the scan, would be to find missing measures. The scale factor, that's part of your vocabulary here, is the ratio of the length of 2 corresponding angles. This is a lot of reading. It's very complicated, so let's read it again. Scale factor, and follow along with me with your finger in your book on page 547. Is the ratio of the lengths ratio. Okay, that's something. So we're going to be dividing, like you see on this side, We're going to be dividing two things. You can also see it here down in example 2. If you preview the lesson, you're going to have a problem in example 2 where you have a side ZY corresponding to DC, or vice versa, YZ congruent to CD. As long as you name it in the same direction, that's fine. These are oriented. We line up. This one is comparing the large quadrilateral to the smaller quadrilateral, so you end up with a division problem. Again, we're just previewing right now, so this is what a preview looks like. It's the ratio of the lengths of two corresponding sides of two similar polygons. Okay, important here. Corresponding sides. That's matching sides on two figures. Your book has done a great job of providing this little area over here. This area is super for making notes, and that's what you should do in that area. Again, we have a big word here, ratio, and the word similar and polygon. Big, big words. You can use the scale factor. That's the dilation factor that we've been working with, called K, of similar figures to find missing measures. So let's highlight that. Dilation factor. So we would go back. The quick, brief thing was find missing measures and similar polygons. So under our quick scan here, similar polygons, and find missing measures of similar figures. And this one was on page 547. And this is on page 546. So let's get on with the lesson. Similar polygons. Polygons that have the same shape are called similar polygons. A polygon is simply it's a multi-sided object. Have the same shape, okay, are called similar polygons. So if you have a triangle, it has to be in the same exact angles that produce the same shape. In the key concept box, there's a triangle ABC is similar to triangle XYZ. This is written as triangle ABC, and now we have a new symbol here. Notice that the equal sign has disappeared, and we just have a curvy line, which means similar. So you can see it up here also, meaning that triangle ABC is not congruent to triangle XYZ because this one's smaller. It's similar, so you'd get rid of the equal sign and just use the squiggle by itself. The parts of similar figures that match are called corresponding parts. That is super important. Corresponding. This is going to be big throughout the rest of the lesson today and for the rest of the unit. It is the most important thing, probably identifying where the corresponding parts are on two figures. Example 1. Determine whether this rectangle HJKL is similar to rectangle MNPQ. Okay. Well, we need to look to see if the corresponding angles are congruent. Okay, well, this red symbol we've discussed before, this red square being in the corners, means 90 degrees. I'm going to put that over here in the notes. If you see a little angle measure that has a squarish thing that completes a square, let's say it's right here. That angle measures 90 degrees. And so we see here in both rectangles, we have a 90-degree angle on all four corners. That's the definition of a rectangle. 90 degrees, 90 degrees, 90 degrees, 90 degrees. So do we have congruent sides? That's yes. So once we have congruent, I meant angles. Once we have congruent angles, then we're going to look at the ratio of the sides. And now we got to set them up. So we have HJ here is 7 over MN. That's this one over here. So let me highlight that. HJ and MN. That's a corresponding side to this triangle compared to this triangle. We're going to compare the small triangle compared to the big triangle. So the small, I said triangle, small rectangle to the large rectangle. So we have HJ over MN is 7 over 10. We have JK over NP, which is 3 over 6. Reduce that, it becomes 1/2. Here we have KL over PQ, and that's 7 over 10. And then we have LH, which is here, over QM, and that also reduces to 1/2. So we end up noticing that 7/10 and 1/2 are not equivalent. So they're not similar. They have to have the same ratio on all the sides. So let's see what we have here on this check problem. Determine whether triangle ABC is similar to triangle XYZ and explain. Okay, well, in this problem we're going to assume it's an isosceles triangle, but we're going to assume that the base angles here, I'm going to mark it with a single arc. Because it's isosceles, both sides are 6. We haven't got to this part of the geometry yet, but in an isosceles triangle, base angles are congruent, and the vertex angle is different. So let's assume that these base angles are congruent, and we'll look at this vertex angle. Okay, so that means that we have AC. If we compare it over XZ, AC is 6 over 8. And then we'll compare the next two sides, AB to XY. AB over XY, that's 8 over 12. And then we'll compare BC over YZ. BC over YZ, that's 6 over 8. So if I reduce this, I can reduce this 2 goes into 6 3 times, and 2 goes into 8 4 times. And here, 2 goes into 8 4 times, and 2 goes into 12 6 times. I can further reduce this as 2/3, and then this is also 3/4. So we have 3/4 here and 3/4 here, but all of a sudden we have 2/3 here, so that is a problem. These are not equivalent, all three of them. So this is not similar. Okay. Moving on to example 2. We have a lot of good space here to be able to write. I'm going to zoom in just a touch. And we've already talked about we need to find the dilation factor. And in this example right here, we have a couple different ways to go about it. We have it given that WXYZ is similar to this other quadrilateral. What is a quadrilateral? 4-sided. 1, 2, 3, 4. 1, 2, 3, 4. Its orientation is really important to look at. So is it arranged in the same way, or do you have to do some kind of transformation? Do you have to shift it in some way? Do you have to twist it? That's called a rotation. Do you need to translate it? Do you need to slide it over? That's a slide. Do you need to reflect it? In this case, it looks like it would be, it's in the orientation, that's okay. So it would, just a dilation and a translation would get it back to its original position. We're not interested in moving it right now. We're interested in finding what the dilation factor is. So A, describe what the transformations that map W, X, Y, Z onto A, B, C, D. And we just talked about that. It would be a translation and a dilation. But B is the important new concept. Find the missing measure. Let's try method 1 first. Find the scale factor. That's the dilation factor, which we call K, from quadrilateral ABCD to quadrilateral WXYZ. So it's already been given that it's similar, so we don't need to prove that it's similar. We just need to compare two corresponding sides. Again, you can't just willy-nilly compare two sides. You got to find the corresponding sides, and they've done this on here. They've done YZ, which is here, and they've done CD, which is here, and so they have 15 over 10 or 3/2. You always want to reduce to the lowest factor, the lowest fraction that you can, and you want to leave it as improper fractions. Fractions are best. Okay, I've also seen decimals are okay. Mixed numbers are not okay. So do not do mixed numbers. Okay, you need to stick to improper fractions if you can. They are best. Okay, so anyway, the length of the polygon is 3/2 times as long as the corresponding length. What do we call that again? That's the dilation factor. So if we had a missing side, in this case we have a missing side M, then we can go ahead and find M by just multiplying the corresponding side. Make sure you're doing it. Notice that this is the smaller triangle. We know this side is 12. And we want to find M. We know that this figure, the figure is 3/2 times larger. So if I'm going to go from here to here, I'm going to multiply. M equals 3/2 times the side that I know, 12. Okay, well, what is that? That's 36/2, and I divide that, it becomes 18. Let's do some quick cross-canceling. I know that this is over 1. I know that's in the denominator, and I know that 2 goes into 2 once, into 12 6 times. So I cross-canceled the 2's, 2 in the numerator, 2 in the denominator, and I'm left with 3 times 6 is 18/1, which equals 18. If I went the other way, if I went from this large figure to the small figure, then I would multiply by the reciprocal of 3/2, because this one is 2/3 as large. So note so going from the large to the small, use the reciprocal. That would look like this. 18 times 2/3. Okay, that reduces. That 18 times 2 is 36/3 is going to give me 12. And I could also do quick cross-canceling. 3 goes into 3 once, into 18 6 times. 6 times 2 is 12. So it's very important that you maintain which triangle you're going from. Okay, or you can set up a proportion to find the missing measures. And that's a slick, quick way to do this. We know 3 out of the 4 sides. We know up here, if I go back, make this a little smaller. If I go back here on this problem and I see, I know x, y. I also know y, z. Well, I don't know y. I'm sorry. I know x, y, which is here. It's m. That's what I'm looking for. I know y, z. And then on this one, I have b, c, and I also have c, d. So you could set it up as a proportion. Just realize that x, y, okay, and BC, if you look up here, X, Y, and BC are corresponding sides. And the same thing here. These two guys are corresponding. Anyway, this is a big deal here. M over 12 equals 15 over 10. Let's take a look at that again. M over 12 equals 15 over 10. We haven't spent a lot of time in class doing cross multiplication, but the main idea is that you can multiply diagonally across the equal sign, and I get 10 times m equals 15 times 12. That's 10m equals 180. I divide by 10 and I end up with m equals 18. Sorry about that. M equals 18. Okay, pause the video here if you need to catch up, but we are almost to the end. We're going to do one final check. Find each missing measure. Okay, remember there was 2 methods here. We're looking for W, Z. That's right here, question mark. Well, let's give it a letter. Let's call it the letter N, since we did M the other place. And we could do it with method 1, where we could find the ratio. What do I know the ratio is of big to small? It is, find the ratio. We did it on the other page. We knew YZ over CD was equal to 15 over 10, which equaled 3 over 2. And so to find WZ, I could just multiply its corresponding side, 13 times 3 over 2. Okay, that's 13 over 1 times 3 over 2. There's nothing that's going to cross cancel here, so I end up with 39 over 2. And leave it like this. Leave it improper. If you want to turn it into a decimal, go ahead, but do not turn it into a mixed number. Okay, let's look at the other one, AB. Let's do it the sophisticated way. Now, notice it's the smaller one. So let's say I called it A, B, C, D. Let's say I call it J, K. Since there's no K in here, let's call it K. Again, we know if now we would have to go from the large one to the small one. We could just simply multiply 24 to find K. We could do 24 times the reciprocal, 2 over 3. And that would be 3 goes into 3 once. It goes into 24 8 times. So we know K is going to be 16. But the other sophisticated way to do it was to put it in a ratio. Let's say DC over ZY equals AB over WX. Those are corresponding. Now we just put the numbers in. DC is 10 over 15 equals AB, which is K, over WX. Okay, I'm just going to, because the space is limited, let's go right here in the green. I'm going to cross multiply, and I have the value of Wx. It's 24. I apologize. So I'm going to go ahead and multiply, cross multiply. I get 10 times 24 equals 15 times k. That's 240 equals 15 times k. And now I have to divide. So k is going to equal 240 divided by 15, which is 16. And that's the end. Your homework is pages 549 to 550, number 1 through 11 for the enhanced class, periods 2 and 3. The other classes is 1 through 7. Period 2, 3, number 1 through 7 for periods 4 through 6. Good luck.